Hi class, we have the 22nd lesson for differentiation of calculus, but this is the fourth example for implicit function. All right, so here, two questions in one. First to find dy dx, and later to find the gradient. But we are given the curve x cubed plus y cubed equal to 4xy. This is the function. But when you have this one on a graph, it will give you a curve. The reason it is just called a curve. What makes it a constant? Whenever you have y equal to what is here, there is no y, just x. We can say it is explicit. We can say what? It is explicit. But whenever y cannot stand alone, you cannot make y the subject, we can say the function is implicit. Yeah, the function is what? Implicit. So this one is an implicit function. So what do? We want to find dy dx. X cubed, what do? Power 3 times 1 is 3. Then the power minus 1 will remain 2. As long as you are differentiating x, no problem. The difference in differentiating an implicit function lies when you are differentiating y and when you are differentiating the term that comprises xy. Okay. We want to differentiate y. We do the same as we did here. 3 times 1 is 3. 3 minus 1 is 2. But because of this is x, this is what we did, just that. But this is y. We don't stop here. Each time you differentiate y, you are charged dy dx. Two different cases. When you differentiate y, are charged dy dx. When you differentiate the term comprises xy, you differentiate twice. Now I want to differentiate for xy. For xy. Any term that comprises xy, you differentiate it twice. You differentiate x, later you differentiate y. So now that we want to differentiate x, let us keep y aside. Yes, the term is for xy, but we want to differentiate x so that beginners will not get it confused. So we say let y wait for us aside. We keep y. If we differentiate 4x, what do we get? We get 4. Now the one that you kept, you can bring it now. So easy. So we say 4y. Can we add y dx? No, because we differentiated x and not y. All right. The term comprises xy, so we differentiate it twice. We've differentiated x. Now it is time to differentiate y. So we have 4xy. We want to differentiate what? We want to differentiate y. So we keep x aside. If we differentiate 4y, what do we get? We get 4. But we bring what we kept, which is this. But remember, we differentiated y, so we must attach dy dx. That is the only thing we do. So plus 4x dy dx. So what do we want to find? Dy dx. So this term and this term, they are the ones that contain dy dx. So this is 3y squared dy dx. We'll bring this closer, minus 4x dy dx, because it is moving, it is coming from another side, equal to, here is 4y. We'll take this to the other side, minus 3x squared. We need dy dx. So dy dx is common, is this one. So if this one takes away this, leaving 3y squared. If this one takes away this, leaving 4x, which is 4y minus 3x squared. But we need only dy dx. So divide both sides by these brackets. 3y squared minus 4x. 3y squared minus 4x. So this takes away this, leaving only the dy dx we want to find. So 4y minus 3x squared, 3y squared minus 4x. So if the question is to only find dy dx, this is dy dx for you. But the question further says, hence, find the gradient of the curve. But we need to understand what is meant by gradients in calculus. When we talk about gradients in calculus, we mean the first derivative. What do we mean by the first derivative? We mean dy dx. Yeah, this dy dx represents gradients. This one again represents gradients. This is representing the Leibniz notation. This is the functional notation. So this is the same as this one. This is dy dx as well. This is f prime of x as well. So when we say dy gradient, we mean the first derivative. So if the question says find the gradient, it means find the first derivative. And this is already the gradient. Find the gradient means find the y dx. So if we are to find the gradient, it means we have to find the y dx, which is already this. Only that at this point. So at this point, so this represents x, this represents y. So wherever we see x, we write 2. Wherever we see y, we write 2. That is the only thing we need to do. Don't forget, dy dx means gradient. So we say at 2, 2, in any coordinate system, the first value represents x, the second represents y. So we say dy dx is equal to 4y. Well, what is y? Y is 2 minus 3 x squared. What is x? X is 2 over 3y squared. 3y squared, y is 2 squared minus 4x minus 4x. What is x? X is 2. X is 2, y is 2. So 4 by 2 is 8. 2 squared is 4. 4 times 3, 12. 2 squared is 4. 4 times 3, 12. 4 by 2 is 8. So at the top, what we have? We have minus 4. Down here, we have 4. So that gives minus 1. So this is the gradient at 2 and 2 as the coordinates. Thank you for watching. Don't forget to follow, like, share, and comment.